challenge, and the challenge we're going to be doing today is going to be called Meerkat. So with this challenge, it's basically a fast-growing startup. Fora has been utilizing business management. Unfortunately, our documentation is scarce and our administration aren't the most security aware. As our new security provider, we'd like to have some look at PCAP and logs before we export to confirm we have not been compromised. So it gives us download set of file. We download the zip. And then as the zip is downloading, we want to see the password, hack the blue. So download it, open it, and then it's gonna extract it. Okay. And then we're just gonna go back right here in our folder section. I'm just close this. And now we have Meerkat. So Meerkat, it gives us a PCAP file which we could open on our Wireshark that I already have installed. So it's gonna open. We believe our business has been compromised. Can you please confirm the name of the application that's running? So we just wait for this to open up. Remind me later. So we look at what's installed within the packet. So let's see. So first we want to see any TCP connections. This is where it starts initially. Transmission. We'll see if there's anything that we could look at, like any kind of web request or anything like that. Let's see, 50. Okay. Let's see. So I guess to understand how this will work is we had to look at every file within the system, but the ones that we could basically look for is that the ones that are basically web requests. So how are we able to find, I guess, web requests that we see? So we need to filter out for specific packets that we can see, or any type of HTTP request. So how will you find HTTP requests? So go back right here. It says we believe our base has been compromised for the name of the application that's running. So let's see if we could do right here. Let's see. Mostly HTTP requests come in both ports, different ports. So how do we find the port that we're looking for? So let's see. Port. TCP port 80. Now this lower down the sequences to things more specific. So let's just see if we got anything right here. Header. So let's see, TCP. We could also try 8080, which is an alternative. So 80. Now we get HTTP requests. So we go right here. TCP, HTTP. And we get Bonita. So we get this host for Relica connection upgrade. We should get something with server something. We get Bonita host. Now that we get server or something. Bonita. So that looks like what the service is running, Bonita. So we'll just copy that. Bonita. Bonita. Okay, so it's not Bonita. Oh, I think I opened up that. So request URI. That's nothing. Close that. Get Bonita. Bonita portal. I guess the question is, could we even go to that site? I guess. Bonita login, same origin. Bonita login. That looks like to be the service, but I'm not sure what the actual name of the full service is. It's Bonita. How are we able to, I guess, see what kind of software it is? So let's see. I think a quick Google search could help us solve this. Bonita business management platform. Hopefully it doesn't give us a write-up. And it does. Bonita is an open source process management workflow. See, Bonita Soft. So let's see, Bonita Soft. So we believe the attacker might be using a subset of brute forcing attack categories. So that means, so I guess that was the correct answer. Now they said that they're trying to log in multiple different times into the event. So let's see. So we see what is the name of the attack carried out. So let's go back right here and look for login. So we get login right here. We're gonna try out different passphrases. So let's see. We're trying out different, I guess, login data. So let's see right here. Bonita. We're trying username, password, install. And if we go right here to the next one, HTTP login service, they're trying username and password app. And then we gotta check every login service. They're trying install. Lauren. Install. Mara. Install. So I guess password, you could look up password techniques. Password brute forcing techniques. Dictionary. Hybrid credentials, rainbow. So we could probably go after here. Dictionary is using a word list containing likely words and phrases based on real world information, but this doesn't look like real world information because it's actually giving us like credentials and stuff, like something that they already know, but trying out different types of passwords and different types of logins. So I don't think it's that. So it's something that they already have or they already know. So it can't be dictionary. So hybrid brute forcing, simple brute force with common words and add permutations. Probably not that because we look at the passwords and stuff, they're just random. So it's probably something they think they already have. Reverse brute force of instead of trying many passwords against a single, this thing tries few against a large list of usernames. It's not a common password, so that credentials is using a list of using pairs that have been stolen from a previous data breach. So this is what it might be, credential stuffing. So if we just copy that and put that right there, we get that. So there's the bottom way. Explain how my CVE assign and which one. So we could probably look up Bonita Soft and then login CVE, and then Bonita authentication bypass leading to RCE, where maybe such as to bypass authorization field, open redirect, authorization bypass. That seems to be the biggest one, so we're just gonna copy that. It might actually not be. It might be this because it ends with a 7-2. Yeah. So which string was appended to the API URL to bypass that string by the exploitation? And I think it tells us the string right here. Technical token validation. What was the string? Either I translation or LM. Oh, how many combinations of username were used in the credential stuffing attack? So this is where you had to use, like, I guess, a bit of filtering, like filtering out specific events that we could see in here. So we could probably do 80/80. I think this does not going to take away anything, right? And protocol. TCP port 80/80 and proto HT. Okay, now we got a little bit more filtering. Okay, now we have to count how many of these there are. So let's see. We see 401, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34, 35, 36, 36, 36, 37, 38, 39, 40, 41, 42, 43, 44, 45, 46, 46, 47, 48, 49, 50, 51, 52, 53, 54, 55, 56, 57, 58, 59, 60. And there's more. 60. I got where you used it. You did I count it wrong, or let's see. Yeah. And post. And let's see. Post. HTTP. Post. Or info. Done. HTTP. HTTP accept. Request line info. Let's see. Request URI. Request URI equals Bonita. Login service. So that's alright then. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oh, we could probably just use ChatGPT. No, we can't. 1, 2, 3. Does it tell us how many packets? It's not gonna tell us. And then it's gonna be tough. This is ChatGPT. Login service. Oh, how many of them were there? Thinking. ChatGPT, gotta love AI. Please tell me. Counting a parcel request occurrence in logs. Oh, it's writing code? Damn. That's not the fun way to do it. Oh, well. You should see it right now. Should be interesting right now. Just gotta wait. How many is that though? How many? You know, if I could ask Microsoft, it's faster. Google AI. That's Gemini. Let's see. Hopefully Gemini, which one's faster, I guess. Analyzing logs. How many post requests are there? It's attempting it, and then right here it's still trying it. Wow, AI is so slow. You could probably. I'm just too lazy to figure this out. What says which user combined was successful? So I'm assuming the one that looks different. Let's answer this one. So everything was 401 up to 204. So I'm assuming 204 was the one that was successful. So was it Seb Room in UK government? So it was this one. So we Seb Broom at for real. It's still counting. Uh, 114.4. Is there room for real? Let's have room for real. For real. .co. .uk. Government. How many combinations were used in the cruncher stuffing attack? So there's around 114 post requests, but we need to look at the ones that the combinations that were tried. So how are we gonna do that? So we had to go back right here. I think how many of them were 401? Wait. 401, and then let's go with length. No, I feel like length. Okay, and how many had different length? What's 140? 112. 114 divided by 2. 57. The only reason I thought of this is because I'm assuming what if they tried it twice. So if there's doubles, so 57. 57. 114, so 113. No. 57, 56. Alright, so it's 56. So that makes it a little bit more easier for us. And the only reason I guess did that as well was because it's like what binary search. You search the top one, the low one, the middle, and then after you just keep on going down until you, I guess, achieve one. It's still analyzing, so I guess we know Gemini is not that good. Let's see right here. 66. Okay, yeah, we were not gonna do that. So anyway, so if any, which text sharing site did the attackers utilize? If any, which text sharing site did the attacker utilize? So alright then, we're almost done right here. If any, which, so we gotta look back at the request, but we gotta simple it out to, we know at 127 once they logged in, they 125, and then it's a 204 because we can't use this request anymore, so we just gotta go like that. 452, let's see right here, HTTP, nothing. Bonita page upload, action add 200. Bonita request page upload 148. I translate JSON. Bonita. Oh, RCE. CMD bash, and they ran this bash script. What's this right here? So they run this bash. Oh, CMD get right here. Paste.io. So basically what they did was they probably ran a get command right here to paste.io, and they were able to get, I guess, this binary right here. So I'm assuming it's paste.io. Paste.io. Please provide file names to the public key used by attacker to gain persistence on our host. So Please provide the file name of the public key used by task. Let's see if we go back to this. The file name, I'm assuming is probably this. Yeah. Oh, CMD, where is it at? Copy the value. Go right here. I'm assuming this is the file name right here. Control C. What? BXGRT. Because this is the raw file name. It's not that one. Go back right here. Raw. Action add set cat Etsy password. Copy value. Go right here. Curl. Oh, this is the what it curls. This value. So it's probably this. Can you confirm the file modified by attackers to gain persistence? It's authorized keys, which is this. It's the file that they modified, and then yeah, matches that. Can you confirm the miter technique of this type of persistence and mechanism? So miter technique. So let's see, SSH authorized technique, miter. What does it want? The ID. What's the miter technique ID, which is found right here? Adds it to the authorized. Yeah, it's probably this one. Then we can load it up right here. Submit it. And we solved it. So yeah, pretty cool challenge. Took me a while because I was just like trying to figure it out, but pretty cool challenge. Nothing bad to say. Pretty much how like a real world, I guess, investigation will go. But yeah, that's about it. Hope you guys learned something new today. I know I did, and I'll see you guys in the next one. Peace.